Okay, welcome to the today's topic, pressure measurement. All of you are most welcome to join in this session, pressure measurement. Okay, fluid pressure and its measurement. What is meant by a pressure in general sense? Pressure is nothing but a force acted upon unit area is called a pressure. Okay, the force acted upon unit area is called as pressure. Okay, when this situation will occur whenever a liquid such as water or oil etc. is contained in a vessel, it exerts a force at all points on the sides and bottom of the container. This force per unit area is called pressure. If F is the force acting on the area A, then intensity of pressure is P is equal to F by A. The direction of this pressure is always at right angles to the surface. Okay, this is a very important thing we have to remember. The direction of this pressure force is always at right angles to the surface with which the fluid at rest comes in contact. Okay, being it is a force, it has a perpendicular direction to that force. Okay, the direction of pressure is always right angles to the surface when it is contact with the surface. Uh, are you seeing the slides? Anyone reply me? Hello, Harish?
Sir,
Slides చూస్తున్నారు కదా?
చూస్తున్నాం సార్.
Okay, right. Next, this is a pressure head. Pressure head. Here we are considering one vessel. Consider a vessel containing some liquid as shown in figure. Okay, we have taken one vessel, we filled this vessel with the liquid. We know that the liquid will exert pressure on all sides as well as bottom of the vessel. Okay, so being weight, liquid will have certain weight, that too the quantity is lying at a distance of or height h meters. It exerts certain force on the all the surfaces which is in contact with the liquid, say top and bottom, right and left, it will act. Okay, now see this. Let W is the specific weight of the liquid. W is the specific weight of the liquid. Okay, and H is the height of the liquid in the cylinder, and A is the area of the cylinder base. There will be some pressure on the cylinder base due to the weight of the liquid in it. Okay, therefore, the pressure is equal to force due to its height in the cylinder by the area. What is the force, pressure force acting on it? WHA. WHA. This is the force. W is a specific weight. W is a specific weight. Understand? How we see, W is a specific weight. Understand? Okay. So, and what is the height of the liquid level in the water container? H. What is the area of the base? A. So, what is the total force, weight, total weight of the liquid presented in the cylinder? WHA. Okay, this is the weight or force due to the weight of the liquid presented in the cylinder by area of the cylinder base. What is it? Capital A. So WHA by A. A will be the gets cancelled. So what are the remainder? WH. WH is the pressure. Okay. See, specific weight, W is also written as rho G. Rho G in first unit, first classes we discussed it. Therefore, what we can write, pressure head P is equal to rho G H. Understand? Pressure head P is equal to if pressure is equal to rho g h, then pressure head h is equal to P by rho g. So from that equation P is equal to rho g h, we can write h is equal to P by rho g. That way we can write. Okay, this equation shows that the intensity of pressure at any point in a liquid is proportional to its depth. From P is equal to rho g h, we are citing pressure acting or intensity of pressure acting at any point in a liquid is proportional to its depth h from the surface. Okay, it is obvious that the pressure can be expressed in each other of the following two ways: as a force per unit area, Newton per meter square, or as a height of the equivalent column. In these two methods, we can express this one. Okay. So pressure is equal to force acted upon unit area. Pressure head is equal to, from P is equal to rho g h, we can write h is equal to P by rho g. That is the thing we have to remember. Say here we are seeing a simple problem. We are seeing one simple problem. What is the thing? A steel plate is immersed in an oil of specific weight 7.5 kilonewton per meter cube up to a depth of 2.5. What is the intensity of pressure on the plate due to the weight of the oil? Okay. So what is the weight here given? 7.5 kilonewton per meter square. And what is the height of the liquid level? 2.5. Understand? So intensity of pressure is equal to P is equal to WGH. Okay, directly we can write what is its weight? Specific weight 7.5, height 2.5. So if we simplify it, we will get 18.75 kilopascal. P is equal to rho g h or P is equal to WH. We can find out the pressure. Next, come for this law, Pascal law. Okay, Pascal law. It states that the intensity of pressure at any point in a fluid which is at rest is the same in all directions. Okay, the intensity of pressure if at any point in a static fluid or fluid which is at rest is same in all directions. So how to prove it? We are considering one small, consider a very small right angled triangular element ABC of a liquid as shown in figure. In next slide we can see Px is the intensity of pressure acting in horizontal direction. Py is the vertical intensity of vertical pressure on the element in the liquid. Okay, so this is the triangular ABC element of the fluid. Px is the intensity of pressure acting on face AC in x direction. Py is the intensity of pressure acting on surface face BC in vertical direction, and Pz is the intensity of pressure acting in face AB in z direction. Okay, let theta is the angle of the triangular element here. Now pressure on the vertical side AC of the fluid element. Okay, Px is equal to pressure on the vertical side of AC is equal to intensity of pressure into length of this side AC. Similarly, pressure on the horizontal side BC, intensity of pressure is Py and length of the side is BC. And pressure on the diagonal face AB is equal to Pz is equal to intensity of pressure Pz and length AB. Since the element of the liquid is at rest, therefore, sum of the horizontal and vertical components of the liquid pressure must be equal to 0. Understand? Sum, that means total forces. In engineering mechanics also we have studied in sigma fx is equal to 0, sigma fi is equal to 0, sigma m is equal to 0. Understand? What is the forces acting? Once again, we will go back. See, P. This is a pressure force Px, pressure force Px, pressure force Py, pressure force Pz. Understand? So these here Py is a vertical force Py and Px also horizontal force. What is the inclined force? Only Pz. If you resolve this Pz into two components, we will get Pz cos theta and Pz sin theta. Okay. So resolving the forces in horizontal way, If we resolve this, we will get Pz into cos 90 minus theta, cos 90 minus theta, cos 90 minus theta is equal to sin theta, Pz sin theta is equal to Px, or Pz into AB sin theta is equal to Px AC. From the geometry of the figure, we will find that AB sin theta is equal to AC. Okay, so Pz AC is equal to Px AC. So if we cancel the AC and AC, we will get Pz is equal to Py. Now resolving the forces vertically. If we resolve this force vertically, okay, what thing we will get? What is the vertical forces? The weight of the liquid is acting downward direction. Py is acting in upward direction, and Pz cos theta is also acting vertically downward direction. If we resolve this and equate it, we will get Pz sin 90 minus theta is equal to Py. No, not like that. Pz sin 90 minus theta plus W is equal to Py. Downward forces is equal to upward forces. Understand? So in next slide we will get in next slide we will get Pz is equal to, here we got it, Pz is equal to Px, and here is equal to Py, weight of the liquid element. If you simplify it, we will get Px is equal to Py is equal to Pz. So we can, this indicates proof of the Pascal law. And confirm atmospheric pressure. Pressure due to the weight of air. Pressure is nothing but pressure due to the weight of the air. See, it is measured by the column of liquid that can support. Atmospheric pressure at sea level is 103 kilonewton per meter square or 103 kPa, and 10.3 meters of water in terms of column, and 760 mm of mercury in terms of equivalent of mercury. These are all the atmospheric pressure. What is meant by gauge pressure? It is the pressure measured with the help of a pressure measuring instrument, in which atmospheric pressure is taken as datum. Gauge pressure is nothing but pressure measured by the any pressure measurement instrument, that is called gauge pressure. Next, absolute pressure is the algebraic sum of atmospheric and gauge pressure is called absolute pressure. And next, one more thing, Vacuum, what is meant by vacuum pressure? Vacuum pressure is nothing but the pressure measured below the atmospheric pressure. Okay, measurement of fluid pressure. Measurement of fluid pressure is done by piezometer tube and barometer. Piezometer tube and barometer. See, this is the simple manometer. Simple manometer. This is one manometer. This manometer is connected to the pipe so that we got a height h, and this is the YouTube manometer. Positive pressure and negative pressure. Positive pressure means the pressure above the atmospheric level. Here section ZZ is represents the atmospheric pressure. So pressure is above the atmospheric pressure. That is why we are calling it as a positive pressure. And here there is a negative pressure. Negative pressure. Understand? Okay, pressure measured below the atmosphere. How can we say this is the pressure below the atmospheric pressure? If this pressure in the inside the pipe is less, then only the fluid will enter into the left side of the limb, because atmospheric pressure will act on the manometric fluid. That is why it rises up in the left limb. So negative pressure. Consider a simple manometer connected to a pipe containing a liquid under a high pressure. High pressure. The high pressure in the pipe will force the heavy liquid in the left limb of the U tube to move downward. This downward movement of the heavy liquid in the left limb will cause corresponding rise of a heavy liquid in the right limb. If the pressure less than atmospheric pressure, then a U-tube manometer fluid will force the liquid presented in the pipe. So it will move at a certain height. Okay. The horizontal surface at which heavy and light liquid meet the left limb is known as common surface or datum. Okay, this datum, this line is shown in figure with the ZZ section. Okay, let H1 is the height of the liquid in the left limb above the common surface, and H2 is the height of the heavy liquid in the right limb above the common surface in meter. H is the pressure in the pipe expressed in terms of head of water in meter. This is corresponding to the previous figure. See this one. Oh, this one. Make it. S1 is a specific gravity of the liquid and S2 is a specific gravity of heavy liquid. S1 is the specific gravity of light liquid. S2 is the specific gravity of the heavy liquid. The pressure in the left limb and the right limb above the datum line is equal. Okay, because from the Pascal law, intensity of pressure is same. We know that pressure in the left limb above the datum line is H plus S1 H1, H plus H1, S1 H1. Similarly, pressure in the right limb above the datum is equal to S2 H2, H2 H2. Since the pressure in both the limbs above ZZ line, datum is equal. Therefore, equating these two pressures, equation 1 and 2, we will get H plus S1 H is equal to H2 S2 H2. Therefore, pressure difference H is equal to S2 H2 minus S1 H1 of the meters of water. Understand? For negative pressure, we will get minus S2 H2 plus S1 H1. This is the mathematical equations we have to remember. And come for the next slide. This is one problem. See, a simple manometer containing mercury was used to find the negative pressure in the pipe containing water as shown in figure. The right limb of the manometer was open to the atmosphere. Find the negative pressure below the atmosphere in the pipe. If the manometric readings are given in the figure, okay. H2 is 50 mm. H2 is 50 mm. This is nothing but height of the liquid column of the heavy liquid. This is H2 and H1 is equal to 20 mm. This is the height of the liquid column presented in the left limb. Okay. And next S2 is a 13.6. Here we want to find out the pressure presented in the tube. So we are assuming pressure head in the pipe liquid is H. Okay. Gauge pressure in the pipe in terms of head of meter. So what is the pressure in the left side? H plus S1 H1 plus H2 S2 H2 S2, because everything is presented above the judged section in left limb. In right limb there is nothing, and pressure head in the right limb is judged is 0 because there is no liquid column presented in the right limb. Therefore, what is the intensity of pressure for the balance, for equivalence? What we will get? H1, simplify this equation, S1, H1 plus S2, H2, H1. S1 is the water specific gravity, S1, into what's the height? 20 mm, plus S2 is the specific gravity of heavy liquid, 13.6, height 50 mm. If we simplify it, we will get H plus 700 mm or H plus 7 meters of water. Therefore, pressure, if you equate it, we will get H plus 7 is equal to 0. Therefore, H is equal to minus 7 meters of water. How we get the minus? Nothing but negative pressure is nothing but the vacuum pressure. Pressure measured below the atmospheric pressure. And this is one more problem. Figure shows a conical vessel having outlet at A to which U2 manometer is connected. Understand, this is a U2 manometer and this is a conical vessel. Reading of the manometer is given in the figure as shown in the vessel is empty. Find the reading of the manometer when the vessel is completely filled with the water. See the dimension. This is H. This height is 3 meters. Width is 2 meters. And heavy liquid level above judged is 200 mm. See, manometer is reading where the vessel is empty. H2 is 200 mm. That is called 0.2 meter. And S1 is equal to 1 because of water. And S2 is equal to 13.6 because it is the mercury. What is meant by this S1 and S2? These are the specific gravities. For lead, H is pressure head of the oil in terms of head of water. First of all, let us consider the vessel is to be empty and judged to be the datum line. We know that pressure head in the right limb is equal to S1 H1, that is equal to 1 into H, that is equal to H meters of water, and pressure head in the left limb is equal to S2 H2, 13.6 into 0.2. So we simplify it, we will get 2.72 meters of water. Since the pressure in both the limbs above ZZ atom is equal, therefore equating the both equations, we will get H is equal to 2.72 meters. 2.272 meters. Now, consider the vessel to be completely filled with water. As a result of this, let the mercury level go down by X meter in the right limb, and the mercury level go up by the same amount in the left limb. Therefore, total weight of the water in the limb is same. X plus H plus 3 is equal to x plus 2.72 plus 3. So we will get x plus 5.72 meter. And pressure head in the right limb is equal to 1 into x plus 5.72. That is equal to x plus 5.72 meters of water. We know that measurement manometer reading in this case is 0.2 plus 2x. Okay, and the pressure head in the left limb is equal to 13.6 into 0.2 plus 2h, that is equal to 2.72 plus 27.2 x. Again, equating the pressure of equation 1, 3 and 4, we will get x plus 5.72 is equal to 2.72 plus 27.2 x. If we simplify it, we will get x is equal to 0.43 meter or 430 mm. Like that, we can find out the levels and height of the pressures in a YouTube manometer. What is meant by micromanometer? It is a modified form of manometer in which cross-sectional area of one of the limb, say left limb, is made much larger, about 100 times that of the other limb. Understand? A micromanometer is used to measuring the low pressure where accuracy is very much important. Understand? Micro means small. Small manometer is used to measure the very less pressures where accuracy is important. See, this is the this is the micromanometer. Understand? Very small size is there. The left, right limb. Right limb is bigger one. Left limb is smaller one. What are the types of micrometers? Micromanometers, vertical tube manometer, inclined tube micromanometer. What is, see the description of vertical tube manometer, micromanometer. Now consider a vertical tube micromanometer connected to a pipe containing liquid, light liquid and very high pressure. The pressure in the pipe will force the light liquid to push a heavy liquid in the basin downwards. Due to larger area of the basin, that fall of heavy liquid level will be very small. This downward movement of the heavy liquid in the basin will cause a considerable rise in heavy liquid in the right limb. See, this is the left limb, right limb. Simply vertical tube micromanometer. If there is any pressure, if the pressure is acting in atmosphere, atmospheric pressure is acting in the liquid present in the right limb, it will pushes up the uh, water liquid level presented in the basin. Okay, so it moves upward and it moves at a height, a slight height above the datum. Let us consider our datum line ZZ corresponding to the heavy liquid level of the level before experiment. Delta H is fall of heavy liquid level in the basin. You have seen it. H1 is the height of the liquid above the datum line. Seen. H2 is the height of the heavy liquid in the right limb, and H is the pressure in the pipe expressed in terms of water. A is the cross-sectional area of the basin. A is the cross-sectional area of the tube in meter square. S1 is the specific gravity of the liquid, light liquid. S2 is the specific gravity of the heavy liquid. We know We know that the fall of heavy liquid level in the basin will cause a corresponding rise in a heavy liquid level. A into delta H is equal to small a into H2. Therefore, delta H is equal to small a by capital A into H2. Now, let us take the horizontal surface in the basin at which the heavy and the light liquids meet as a datum line. We also know that the pressure in the left limb and right limb above the datum line are equal. Pressure in the left limb above the datum line ZZ is equal to H plus S1 H1 plus S1 delta H, and the pressure in the right limb of the data above the datum line S2H2 plus H2 delta H meters of water. Since the pressure in both key limbs above the ZZ datum is equal, therefore equating the two pressures H plus S1 H1 plus S1 delta H is equal to S2 H2 plus S2 delta H. So if you simplify it, we will get this equation. S2 H2 plus S2 delta H minus S1 H1 minus S1 delta H. Write S2 H1 as well minus S1 H1 as well, plus in these two terms delta H is common, so make it common. Delta H into H2 S2 minus H1. So here what is the expression? Delta H is equal to S2 H2 minus S1 H1 plus A by A into H2. From the above equation 1, A by A, small a by capital A into H2 is equal to delta H. So in place of delta H, we can write A by A into H2 into S2 minus S1. So next slide, we can get H is equal to S2, H1, H2 minus S1, H1. Okay, if the cross-sectional area of the basin is too larger than the tube, the ratio capital A by, small a by capital A is extremely small and can be neglected that two terms. That is why what are the remainder terms? H2 H2 minus S1 H1. So from this we can find out the pressure here in the pipe connected to the micromanometer. This is the inclined manometer. See, this limb is inclined. It is making an angle theta with the horizontal surface. Okay. So, what is the height of the heavy liquid in the manometer tube above the common datum ZZ is H. Length of the liquid level presented in the manometer is L. This is the inclined manometer. See, simple one problem on a micromanometer. In order to determine the pressure in a pipe containing liquid of specific gravity 0.8, micromanometer was used as shown in figure. See, this is a micromanometer, vertical micromanometer. This is connected to a pipe. The ratio of the areas being in the limb is 50. Find the intensity of pressure in the pipe for the manometer reading is shown in figure. This height is 200 mm and 200 mm and this height is 100 mm. So how to solve this problem? See it. First write down S1, the specific gravity of the light liquid 0.8. Capital A by A is equal to 50. H1 is equal to 100 mm. H2 is equal to 2000 mm. 200 mm. And S2 is equal to 13.6. How can we get this? Because so mercury specific gravity is 13.6, constant value. We now consider the pressure head in the left limb ZZ. So consider it, what is the expression? H plus S1H plus A by A into S2 H2. Okay, substitute the values. H plus S1 0.8, H1 100 plus Capital A by A is equal to 50. Therefore, small a by capital A is equal to 1 by 50. 1 by 50 into 0.8 into 200. This is the pressure intensity in the left limb. Similarly, pressure intensity in the right limb. S to H2 plus A by A into S to H2 equal 13.6 into 2000 plus 1 by 50. Simplify it, we will get 2774.4 meters of water. So pressure in both limbs are same because intensity of pressure is same in all directions as per the Pascal law. Okay, if we simplify it, we will get H is equal to 1691.2 mm of water or 2.691 meters of water. So intensity of pressure in the pipe P is equal to WH 9.81 into 269.1. Okay, if we will get 26.4 kilonewton per meter square or 26.4 kilopascal. In this way, we have to solve the problem. See, this is the differential manometer. This is the differential manometer. This device is used for measuring the pressures. This device is used for measuring the pressures between 2 points of pipe or two different pipes. See, this is pipe A, this is pipe B. So, if you want to find out the pressure difference in these two manometers, in this way we have to connect the YouTube. Sorry, YouTube manometer. Z is a section which represents the atmospheric pressure. Understand? Height of the manometric fluid in right limb is H. Height of the liquid presented in the pipe B above the datum is capital H. Okay, so this is the height of the liquid presented in the left limb is uh, H plus capital H plus small h. Like that we have to find out. And let us take the horizontal surface ZZ at which the heavy liquid and light liquid meet in the left limb as the datum line. Like H is the difference of levels of the heavy liquid in the right and left limb, and also known as the reading of the differential manometer. HA is the pressure head in pipe A, HB is the pressure head in pipe B, S1 is the specific gravity of the light liquid in the pipe, S2 is the specific gravity of the heavy liquid. Otherwise, okay. We know that pressure head in the left limb above the datum ZZ is equal to HA plus S1 into H plus capital H plus small h. That is equal to HA plus S1H into S1 small h. Okay, meters of water. Take it as equation 1. And pressure head in the right limb above ZZ. HB plus S1H plus H2H. Equation 2, assume it. And since the pressure head in both limbs above the ZZ are datum level, therefore equating the two equations 1 and 2. So HA plus S1H plus S1 small h is equal to HB plus S1H plus S2H. Okay, if we simplify it, S1H both will get cancelled. HA and HB, HA and HB, this is equal to S2H minus S1H, that is equal to H into S1 minus H2. Okay, this is the pressure difference between left and right limbs. Now consider a small differential manometer whose two ends are connected in two different directions, A and B, containing different liquids at different levels. Let us assume that the pressure at the point A is more than the point B. A little consideration will show that the greater pressure at A will force the liquid to move downwards. This downward movement of the liquid in the right left limb will cause a corresponding rise in the heavy liquid in the right limb. The horizontal surface at which heavy and light liquids meet the left limb is taken as datum. Okay, in this case, ZZ will be the datum. Okay, see this. Here we are considering YouTube differential manometer. See in the first figure, pipe A and pipe B are at the same levels. Okay, pipe A and pipe B are at same levels measured from the datum line. But considering figure is different. Considering A is lying at a different height and B is lying height from the datum line ZZ. Okay. Here the pressure in the pipe B is less than the pressure presented in the point A. That is why the liquid presented in the pipe A will pushes the liquid presented in the manometer, and hence manometric fluid will rises up, and this manometric fluid pushes the liquid presented in the pipe B. Okay, this how this phenomena takes place means fluids will flow from high pressure zone to low pressure zone. This is the thing. Let H1 is the height of the liquid in the left limb above the datum line in mm. H2 is the difference of levels of the heavy liquid in the right and left limb in mm. H3 is the height of the liquid in the right limb above the datum line. HA is the pressure head in the pipe A. HB is the pressure head in the pipe B. S1 is the specific gravity of the left liquid in the pipe A. S2 is the specific gravity of the heavy liquid or manometric fluid. S3 is the specific gravity of the liquid presented in the right pipe B. We know that pressure in the left limb above the datum line ZZ is HA plus S1 H1. Okay, and generally pressure will we will express it in meters of water, and pressure in the right limb above the datum ZZ is equal to S2 H2 plus S3 H3 plus HB meters of water. Since the pressure in both the limbs above ZZ data, so we can equate these two. Therefore, equating these equations, we will get HA plus S1 H1 plus H2 H2 plus S3 H3 plus HB. So what we can write, next step, HA minus HB is equal to S2 H2 plus S3 H3 minus S1 H1. By using this equation, we can find out the pressure difference presented in the two pipes which are lying at different levels measured from the common datum line ZZ. Okay, this is the simple information regarding the pressure measurement by using manometers. Okay, before closing the session, I want to ask you some questions. Okay, what is meant by a pressure? Tell me. Pressure is nothing but the force acted upon unit area. Then what is measurement by a pressure head? Understand, pressure head. So pressure head is nothing but the intensity of pressure directly proportional to the height of the or depth of the liquid level presented in the vessel. Understand? So this is P is equal to rho C H. From this expression, we can write H is equal to P by rho G. And what is the statement of intensity of Pascal statement? Intensity of pressure is same in all directions. So we can prove by considering one triangular element. We can prove Px is equal to Py is equal to Pz. And how can we measure what is meant by atmospheric pressure? Atmospheric pressure is the pressure exerted in the atmosphere due to the weight of the air. Understand? And next, what is meant by gauge pressure? Gauge pressure is nothing but the pressure measured with a measuring instrument. Is called gauge pressure. What is meant by absolute pressure? The sum of atmospheric pressure and gauge pressure is called absolute pressure. Then what is meant by a vacuum pressure? Vacuum pressure is the pressure measured below the atmosphere. Understand? What are the devices used to measure the pressure? Manometers. What are the manometer? Manometer is a device which is used to measure the pressure. What are the types of the manometers? Simple YouTube manometer and differential manometer. And in simple YouTube manometer, there are two types: upright YouTube manometer and micro manometer. And micro manometer are two types: upright micromanometer and inclined manometer. Okay, what is the purpose of the micromanometer? Wherever pressures are very less than the atmospheric pressure and accuracy is very much important, there we will use this micro manometer. What is meant by differential manometer? Differential manometer is a manometer which is used to measure the pressure between the two different points of the same pipe or two different pipes. Pressure difference between two different pipes. Understand? So these two different pipes may be lie at same height or at two different levels. Understand? By using the appropriate equations, understand, which projects on the manometers, we can solve the problems also by considering pressure intensity is same in all directions. Pressure acting in the left limb is equal to pressure acting on the right limb. This is the summary of the today's class. Understand? By tomorrow we will meet you again. You can leave now. Thank you very much. All the boys, goodbye. We can you can leave now.
సార్ ఎగ్జామ్ ఫీజు ఎప్పుడు కట్టాలి సార్? ఎగ్జామ్ అది వచ్చింది అప్డేట్.
ఏంటమ్మా?
ఎగ్జామ్ అప్డేట్ వచ్చింది సార్, 23 లోపల ఫీజు కట్టాలని.
ఏ ఎగ్జామ్ సార్? 2-2
ఎగ్జామ్ సార్.
యూనివర్సిటీ ఎగ్జామ్స్. ప్లీజ్
సార్.
వెయిట్ ప్లీజ్ 1 minute. Now tell me.